Hello students, this is an overview of assignment 5 which builds on assignment 4. Again, I direct you to the assignment 5 notes which have a lot of detail and explanations which would be very helpful to you. A template again has also been provided. I will expect that by this time you have finished writing assignment 4 and tested it because you will be needing the code. And the code for ListNode.cpp is not given to you because you would have worked on that and have it ready to go up and running. What are we doing in this assignment? Here, what we are doing is the methods that we wrote in the driver in assignment 4, we are going to move them into a class called LinkedList, which is a templated class. And just like we did for vector ADT, we created a dynamic array and then we put it inside a abstract data type. We're going to take these methods and put them into an abstract data type called linked list. Now, linked list is built up of ListNode. So you will be including, you will have several files that you will need. You will need the list node.h, listnode.cpp.h. And also now we are going to create the linked list with nodes that store songs. So you will need your song.h and song.cpp.h, your song database files, and all of that. So basically the linked list class, it offers the insert, delete, add, and search methods, which are now called get. As an abstract data type, it offers them as an API. And in the driver now, all we need to do is create the database. There's some things that I'd like to point the attention is that the two things that we are going to do. The first is we will create a dummy database consisting of songs that I have just randomly created and test out all these methods on that database. So we'll create the database and test it out. The other thing that we will do is we will do the sorting in a slightly more, I'm not going to say efficient manner, but implementationally cleaner. Previously and I will show this to you when you come to the template, we were using less than and less than equal to class, and now we have converged them into one sort by class, and we will see how the use of a parameter or a custom constructor in our function objects can help us save on code duplication. So the other thing that is different between 4 and 5 is the implementation of the add method. There, the add method was traversing the entire linked list and then adding to the back, and that caused the complexity to be of order n. It didn't have any value because it was not even keeping it sorted. It was just adding at the back. So now we go ahead and try to make our implementation. The idea is think of ways to make the implementation more efficient, and then we are going to add in the front of the queue, right? Because in any case, it's going to be unsorted, and that is an order 1 operation. So we save ourselves all of that linked list traversal, which can be huge if there are millions of nodes. So I think I have covered these parts. The other features are we want to be able to measure the efficiency. So our insert and remove methods are going to count the steps and return the steps. So that feels a little clunky, but it's not usually there in an API, but because we want to measure. The other thing I'm going to encourage you to do is to time clock the execution time by using the information from your discussion on how to introduce a chronological timer and how to measure execution times of methods. So now here, couple of methods that you may need to add for the remove method, because you have to compare songs, overloading the not equal to and compare equal to, because if you're searching for a song, then while it's not equal to, you have to keep moving ahead, and then double equal to, and if it is equal to, then you have to do something. I do admit that not equal to is not really necessary. I could have used the less than equal to, but here it is. You have some more operators overloaded. So this notes goes over what you need to do, and some chat that is helpful. Now here's the actual template that's given to you. It consists of the main.cpp, which is now completely written. You don't need to change. It's completely given to you. So I'm going to write here given. What does it do? It tests the dummy database, creates a database now using the linked list class, and it is now templated. You're creating a song, database of songs. Now what we are doing is we're creating a function object and passing true, which indicates please sort by title. If I had changed this to false, it would have done, and I encourage you to try this out. Change it to false, it will sort it according to chart position. So that is amazing. We don't, like in the past, we had rewritten selection sort, one for less than and the other for less than equal to. We don't need to do that anymore. The insert method can remain exactly the same. Now, the other thing we're going to be doing after testing the dummy database is we are going to pull in all the songs from the database and populate the linked list. That's what we are doing here. And then we're going to report the number of steps, right? So populate database has been given to you. The test database is also given to you. And so all of this code in the main program is completely given to you. Don't need to make any change to that. In fact, I might just, for every single method, I might just go ahead and say given, because all of this stuff is given to you. So what do you need to write? So what you do need to write is, you see the ListNode.h. Well, the ListNode.cpp.h is not going to be given to you. So it's just blank here. It says to do. So you will need to pull it out from assignment 4. You have been given a linked list abstract data type header file. The class file is given to you to get an idea of what methods need to be done. Some methods, the constructor is given to you, some methods are given to you, and the add method is given to you. The print list method is given to you. So the methods that you need to actually write are the insert and the remove method, if I'm not mistaken, the to do. So the remove method needs to be done, and here the get method needs to be done. So there are two get methods. The first one returns a node based off of its index, not chart position. So element, say if you pass index 0, it's going to return the first song. That song could have chart position 1, it could have chart position 2, it could have any chart position depending on how deletions have been working, and it will return that song, right? So that is what you need to do here. This one, the second get, takes a song and searches for that song by title and returns that same song if it is found. If it is not found, it just returns a blank song. So you will know if your input search song matches the return, then you found it. If you've got, otherwise you've not found it and you just report it as blank. And then here is the remove method, which also needs to be written. And these insert and remove methods can be a little tricky because you have to make sure that the links are correctly reestablished when you insert and delete. And I would strongly recommend looking at the insert and delete from your ListNode to see how it is done. And if your insert and delete are working in your ListNode, then there's a good chance that everything is going to be okay here. So please run this with song database and songs data.txt, song double data.txt. The sort by functor is given to you completely. I'm going to write given here, because you see now I've introduced a constructor, less than equal to and less than did not have a constructor. And if it is yes, if the user creates an object with and initializes this search by title to yes, then sort by title to yes, then you sort by title, and then you return the less than equal to operator, which has been overloaded in the song class. Otherwise, then you sort by chart position. So this code has also been given to you. Now here is the output. Here's what the output is going to look like for song database, song data. This is what it's going to look like for song data double, right? So all of this code is available, and you have to write a few implementations to get it going. And hopefully if assignment 4 has been up and running, then you should be good to go with this one.